Hey guys, welcome back to my channel. My name is N Tejas and I'm studying in Sri Venkateshwara College of Engineering, 3rd SEM CSE branch. So, today's topic is understanding stacks and queues in data structures. Let us begin with understanding what is data structures. Data structures is a way of organizing or storing data efficiently for computer algorithms. Stacks and queues are one among the fundamental various computing tasks that are involved in data structures. Now, let us see the types of data structures. There are mainly two types of data structures, that is, primitive data structure and non-primitive data structure. Primitive data structure examples are integer, float, character, and boolean. Whereas non-primitive data structure is again divided into two parts, that is linear and non-linear data structures. The examples for linear data structures are arrays, linked lists, stack and queues. For the examples for non-linear data structures are trees and graphs. So among all these examples, we are going to learn about stack and queues in this video. So let us begin by learning about stacks. Stacks works on the principle of REFO, which stands for last in first out. For example, here we can see a stack of books. In the stack of books, the book which is placed in the last, which is this book, will be removed first, and the book which is placed first, which is this one, will be removed last. Which means the book which is placed first will be removed in the last, and the last book placed will be removed first. This is a basic principle on which the stacks works. Application of stacks. Applications include reversing words, undo mechanism in software, and backtracking algorithms like maze solving. Implementation of stack. So here stacks can be implemented using arrays or linked list. Each allows efficient memory management for dynamic stack sizes. Here is an example for stack implementation using array. First, the stack is completely empty. Next, the we are pushing an integer 7 into the top. And one thing to remember is uh, in stacks we can remove or insert an element only in the top indexing. So the top indexing begins in 0. While programming will initialize the top to 0. Hence the top variable starts from 0. First we are adding the element 7 to the 0th index. Then we are adding the 8th, we are adding an element 8 to the indexing 1. Then and by while adding each and every inserting each and every element, the top value gets incremented by 1. Here you can see in the first step it is 0. Next the top becomes 1. Next here the top becomes 2. So we are inserting three elements here, that is 7, 8 and 9 after each and every step. Then we are inserting fourth element, and hence the top will again be incremented and the indexing value will become 3. So this is a simple example to show how stack implementation occurs using arrays. Now let us come to queues. Queues works on the principle of FIFO, which stands for first in first out. Here, a simple example of queue is number of cars waiting in a queue for parking or something. So the car which comes in the first will enter first or leave first, and the car which enters last will leave in the last. So first in first out and last in last out. The other applications of queues are it is used in music applications like Spotify, Wink Music, and in everyday applications like we wait in queues to in supermarkets for billing, etc. Applications of queues. Applications of queues include job scheduling in operating systems, simulations, and data streaming management. These are the applications which are used in the computer world. Implementation of queues. Queues can be implemented using arrays or linked list. Circular queues offer efficient space utilization. One thing to remember while inserting and deleting an element in queue is during insertion we insert an element from the rear end and deletion occurs at the front end. During insertion, first we increment the element and then we add the element. But during deletion, we delete the element first and then increment the element. In both the cases, incrementation is common. And one disadvantage in queues is uh, it it causes memory wastage. This disadvantage can be overcome with the help of circular queues, which helps in better memory management. Stacks versus queues. Let us know the difference between stacks and queues. Stacks. Objects are inserted and removed at the same end. Queues. Objects are inserted and removed from different ends. In stacks, only one pointer is used. It points to the top of the stack. Whereas in queues, there are multiple ends, that is rear end and the front end. In stacks, last inserted object is first to come out. That is, it follows the principle of last in first out LIFO. Whereas in queues, the object inserted first is deleted first. That is FIFO, that is first in first out principle. Next, stack operations are called push and pop operations, whereas the operations in queue are called NQ and DQ. Stacks are visualized as vertical collections, whereas queues are visualized as horizontal collections. Collection of dinner plates at a wedding reception is an example of stack. Uh, or collection of books is a pressed one over the other is also another example of stacks. Whereas queue, people standing in a file to board a bus is an example of queue. Other examples are, as I mentioned, apps such as Spotify and Wink. We queue the songs which we want to listen after the current song. This is another example of queue. Conclusion. Stacks and queues are fundamental to algorithm design and data management essential for various computer applications. Thank you. That's it for the video. If you like the video, please do like, share and subscribe the channel. Thank you.